Photographers use color temperature to adjust lighting and color balance. So, what's your preference? Warm yellow or cool blue? Curious about the physics behind it? Alright, anyway. So the system temperature is the result of the constant collisions and motions of constituent particles. Now, a swift glance through conversion of internal thermal energy. Let's first talk about objects emitting, and hence, thermal radiation. Now, what about objects absorbing? So, how do we connect color with temperature, as we do in photography? The colors observed for any object are the product of the light photons, emitted by the object, or reflected by the object. Photons have different wavelengths depending on their energy. Low-energy photons are perceived as red. On the other hand, high-energy photons are perceived as blue-violet. At temperatures around 900 Kelvin, part of the radiation becomes visible in the 700 nanometer region, and the object starts to appear red-hot. At higher temperatures, the color of the radiation turns yellow, white, bluish-white, and eventually blanched blue. A relatively low-temperature object, such as a blacksmith hammering an iron rod in the forge, glows red. Whereas, a higher-temperature object, such as the surface of the sun, appears yellow or white. Burning candle flame, sunset, sunrise are at about 2000 Kelvin on the color temperature scale. Incandescent light bulbs are about 3000 Kelvin on the color temperature scale. Daylight is about 5000 Kelvin on the color temperature scale. A cloudy day with overcast sky is about 7000 Kelvin. Clear blue sky is about 10,000 Kelvin. Please remember to like, subscribe, share.